Where did my pen go? There you are. Okay. All right. So last time we had talked about the definition of a logarithm, right? Yeah. Well, not last time. Last time you guys just had a study hall because Mr. Kulik was going to the hospital, but we had defined a logarithm. So this basically says that the logarithm is going to be the exponent for some exponential problem, right? It tells you like what power of b gives me y. So as we get as we move into starting to use these logarithms, it's important that we understand or have rules for like what we can and can't do with a logarithm, right? So let's talk about some properties of logarithms that discuss like how we can use these two things or how we can use these logarithms. So the first one is called the product property. That says log base b of x times y is equal to log base b of x plus log base b of y. And now that looks a little strange, right? But if you recall, when we multiply two exponentials, we add their exponents, right? So what we're seeing here is that like multiplication outside of an exponential turns into addition inside the exponential. We're seeing the opposite for logarithms, where multiplication inside the logarithm is turning into addition outside the logarithm. It is the exact same property as that exponential property. It's just like the logarithmic version of it. Does that feel okay? The next one is the quotient property. And this says that division inside a logarithm is equal to subtraction outside the logarithm. Again, that's really the same thing as the division property for exponents, right? If you have x to the a divided by x to the b, that's the same thing as x to the a minus b. We subtract exponents. Next one is the power property. So here we have that an exponent inside a logarithm turns into a coefficient outside the logarithm. This is related to the power of a power property, that an exponent of an exponent turns into the product of the two exponents. That this is essentially the logarithmic version of that property. And those are the big three that are super useful. There is a fourth that when I was a student was very important, but you guys as students is much less important. Which is called the change of base formula. So again, when I was a student, the calculator technologies that were standard in a classroom were considerably less powerful than they are now. No one had a graphing calculator in a high school class that I ever saw. Now they existed, they were bad versions of them, but like there were graphing calculators. I think there were 81s and 82s were what they had then. But for the most part, a lot of students didn't even have like a good scientific calculator that had like sine, cosine, tangent even on it, or had ability to do a logarithm on it. So what a lot of the time we end up having to do is we had to look up the values of logarithms out of these tables in the back of the textbook. So if I want to do something like log base 2 of 5, the logarithms in the textbook only were log base 10 or were only natural logs. So I had to use the change of base formula to take, log base 2 of 5 and rewrite it as the common log of 5 over the common log of 2. Look up those values in the book and then divide them on my 4-function calculator. So it was like life was kind of a hassle. Now you guys, your calculators, you can type in log base 2 of 5 directly. You don't have to mess around with that. But the change of base formula used to be like really integral to being able to do anything with a logarithm because you had to look this stuff up. And even the scientific calculators that we had started to become commonplace usually only had log 10 and log e. They didn't have, log of any base option on them. So again, you're still stuck using, you didn't have to look stuff up in a book, but you still had to use the change of base formula like every single time you had to do something. So you guys are less kind of tied to that. So the 3 that we're going to see primarily are going to be these 3. Everybody's cool? Okay. Do you like it when I give you the way back in the day stories about how math was different? I think sometimes it like provides a little context of like, why is this thing in here? It's like, oh, okay, so this used to be really, like you had to have this to do anything. But now my calculator just does it for me, so. All right. So there's really kind of be 2 types of problems that we're going to talk about today. Those are expanding a logarithm, and then the other would be condensing or compressing logarithms. So to do either one of these 2 things, we're going to be using the 3 properties that we highlighted above, the power, product, and quotient properties. For expanding, we go quotient, and then we do product, and then we go power. When we're condensing, we go the opposite order. So we go power, and then product, and then quotient. Unless there's some like set of parentheses that would imply that we should be doing something in a different order, right? And these were problems that we did last year in our Algebra 2 class. Hopefully this sounds not unfamiliar right now. So let's kind of do some expanding examples. So when we're doing expanding, when we're using these properties, we're going to be looking at using the left-hand side. And then when we're condensing or compressing, we'll be using the left or the right-hand sides, just as a aside. Okay. So we're expanding here. The first thing I look for is a quotient property. If I look inside the logarithm, is there any division going on? No. So no quotient property to do. Next thing we look for is product property. Is there any multiplication going on? Yeah, right? There's a multiplication going on between the 4 and the x. Now notice that we don't write a multiplication symbol there, but we know there's one there. So if we apply the product property there, we'd write log base 3 of 4 plus log base 3 of x. Everybody happy so far? Okay. Now let's look at each of these. So we're looking inside the logarithm still. Do we see any quotient properties going on in either one of them? No. Any product properties going on? No? Okay. Any power properties going on? No? Okay. Well, I've been tricky here because there is something more we can do. Notice the number 4. 4 is not prime, correct? So we could write 4 as either 2 times 2, or probably what I prefer is 2 squared. So there is a power property hiding there in the number 4. Now, if 4 was a prime, if that was like 5 or something, we would definitely be done at that point. But here we can go a little bit further using the power property. So we need to be careful about those constants. If they are not a prime number, there's probably either a power or product property that could be going on also. Is everybody cool with that though? Okay. Let's do another expanding one. So here we have the common log of 3ab to the 5th. Again, we're starting by looking inside the logarithm. First thing we look for is quotient property. Is there any division going on inside? No. Okay. Next thing we look for is product property. Is there any multiplication going inside? Yeah. How many multiplications? 2, right? There's a multiplication between the 3 and the a, and between the a and the b. So I'm going to have log of 3 plus log of a plus log of b to the 5th. Everybody happy with that? Okay. Looking at log of 3, quotient property. No. Product property. No. Power property. No. Why not? Because it's prime, right? There's not 3 isn't 2 things multiplied together, so nothing to do there. We go to the A, quotient property. Nah. Product property. Nah. Power property. Nah. Okay, we're good there. B to the 5th, quotient property. Product property. Power property? Yeah. So we can do one more thing to that. How would we write that log of b to the 5th? The 5 becomes a coefficient. And that's it. Just feeling familiar? We spent a good bit of time usually in the Algebra 2 class doing this. Let's do one more here. All right, here we have the natural log of 2x divided by the square root of x cubed minus 5. So again, we're looking inside the logarithm. First thing we look for is a quotient property. Yeah, we got two things being divided, right? So when we apply the quotient property, we're going to have log of the numerator minus log of the denominator. Everybody feel good there? Okay. Let's look at the natural log 2x now. Quotient property. Is there one going on there with log 2x? Nah, man. Product property? Yes. Okay, so let's apply that. So that's going to be natural log 2 plus natural log x. Now let's look at the natural log of square root x cubed minus 3. Quotient property. Product property. Power property. Okay, what's the power? 3 is not correct. The power is 1/2. What? Yeah, remember that a square root is the same thing as a 1/2 power? Everybody's cool there? So far, so good? Okay, let's check these now. Can I do anything more with the natural log of 2? No. Can I do anything more with the natural log x? No. Can I do anything more with the natural log of x cubed minus 5? What do you think we can do with that? You guys said yes. You can't move the 5 out, and you can't move the 3 out. The reason, Claire, is if we had this, then we can use the power property on it. We don't have that, though. The exponent is only being applied to the x, not to the entire quantity. So there's nothing more that we can do with that piece. Does that feel okay on the difference there, Landon? Yeah, of course, dude. So that's as far as we can go. All right. Let's do one more. Okay. What should I write first? Somebody tell me, please. Which property am I using first here? Quotient. How do I rewrite this after using the quotient property? Log base 2 of 3 minus, good, log base 2 of xy. Great. Everybody feel good there? Log base 2 of 3, anything I can do with that? Nope. Oops. As far as I can do or can go with that. How about log base 2 of xy? What can I do with that? Product property is correct. So how would I write that? Log base 2 of x plus log base 2 of y. Okay? Here's the problem. What we've written here is not correct. Take a moment, look at it, see if you can see the problem. It's very subtle. And this is, in my experience as a mathematics teacher, teaching this particular set of skills for about 10 years, the most common mistake made in this set of skills. So here's the issue. This is negative, right? Everybody agree with that? So the stuff that it becomes all needs to be negative. So the way we need to write this is really log base 2 of 3 minus log base 2 of x minus log base 2 of y. Remembering to distribute that negative through a product property is the most common mistake I see in students doing these expanding problems. We're going to talk about it now. I'm going to make a big deal about it now, and I would bet that come test time, 50% of us will make the same mistake and not catch that. The cue when looking at the problem should be when you see a product going on in the denominator of a fraction, right? If you see more than one thing multiplied in the bottom of the fraction, you know you're going to have to do that distributing going on later. Okay? Let's do some condensing problems. So here we're going to take many logs and write them as a single logarithm, if possible. Okay, so remember for expanding, we're looking at what's going on inside the logarithm. For condensing, though, we're going to be looking at what's going on outside the logarithm, right? So we're looking at addition, subtraction, and multiplication of a constant. And remember the order in which we do things for condensing. We're going to do power first, then product, then quotient. So, if I look at my problem here, do you guys see any power properties? You should see 2. Because I have a coefficient here and a coefficient here. Remember, we're using the right-hand sides. We're concerned about what's going on outside the logarithm when we're condensing, not what's going on inside the logarithm like we are when we expand. Is everybody okay? So if I apply the power property then, I didn't do anything to the first piece. Oops. So there's that. Everybody feel good? Okay, next thing we look for is product properties. Do you guys see any product property? Yes. How many? Just one. What is our symbol that cues us that there's a product property going on here? The addition. Very good. Okay. Last thing to look for is quotient properties. Do you guys see a quotient property? What do you guys say? Yes? No? Look a little bit more carefully. The answer should be no. Why is it no, even though there's a subtraction symbol there? The bases of the logarithms are different. Notice the bases of the logarithm are different. One is base 4, the other is base 5. If you go back and you look at the quotient properties, they require the bases to be the same. Oh, there's the property. So at this point, there's nothing more to do. We've condensed it as much as we can. That was a sneaky trick, Mr. Kulik. But this is why we're doing the sneaky things in the example, right? So I can't trick you later on. I'm going to show you all my best tricks so that I can't fool you later, right? It'd be rude if I was like, I'm going to save all the really sneaky things. Ha ha ha. You know? And just be mean. All right, let's do another. Okay. So we have 4 natural log of A minus 3 natural log AB plus 2 natural log B. Again, we're condensing, so the first thing we look for is the power property. Very good. Do we see any power properties? Yes. How many? 3. So I'm going to have natural log of a to the 4th minus natural log of ab to the 3rd. Notice the parentheses there, and then the natural log of b squared. Because when I have an exponent of a product like that, what does that really mean? So I'm going to start writing as a to the 3rd, b to the 3rd from here on out. Is everybody okay with what I did there? Okay, I just wanted to point that out to you guys. Make sure I'm being really clear about how I'm simplifying things. Okay. Next thing up is looking for what? Product properties. Very good. Do you guys see a product property here? What are we looking for product properties? Addition. Do we see addition? Yes. Okay. What 2 logarithms does the product property apply to? It's actually those 2. Why? Because the other one is negative, yes. So that's a little bit sneaky there. But again, this is why Mr. Kulik's showing you the sneaky things, so that he can't trick you later on. You know what I mean? Landon.
Can you re-say why so it's not with the negative one because it would be a negative base?
Right. So if you go back, if we go back and look at the product property, notice that both the logarithms are positive. That's the issue. That if I go down here, the one that I've underlined in green is negative. That's why we're not using it in the product property. Okay. All right. Okay. Now, finally, last thing we check for is quotient property. Do we see a quotient property here? Yes. So I'm going to have the natural log of AB, or a to the fourth b squared over a cubed b cubed. And really, we could reduce this fraction inside the logarithm, right? So I'm going to have an a left on top and a b left on bottom. Is everybody okay with how I reduce that? It's pretty standard, easy reducing there, but I figure I should ask before I just write it down and be like, yeah, you guys get it, don't you? Don't you? Don't you? Let's do one more example, and we'll probably call it good for the day. Sound good? Yes? Sure. So we have the log of x minus 2 log of y minus 3 log z. First thing we look for is power properties. Do we see any power properties? 2 of them. Yeah, right here and right here. Everybody agree? Okay, what do we check for next? The product property. Do we see any product properties here? So there is a product property here, and it is hiding in the one with the 2 negatives. So notice that I could factor a negative sign out of there. And it would look like that, right? Did you guys see that? And there is my hidden product property. What does this remind us of? Remember this problem back here where we had to distribute the negative? Condensing is the opposite of expanding, right? It's the opposite direction. What's the opposite of distributing? Factoring. This is the exact same situation, just running backwards. Yes, precisely. Again, this is the single most common mistake I see students make in this sort of problem, is forgetting to do the doing like a double quotient property or something here rather than do that factoring piece. And then there's the quotient, and we're done, right? Everybody feel cool? All right. This feels like a good place to stop. This puts us back on sequence with the other class, which is great. And I think we should be able to do all the way up to 98.
Is that gonna be due this week?
Yeah. So what do we have now? I know, but here's the thing, guys. Here's the thing. Do you think Mr. Kulik's actually going to be checking on Monday?
Something tells me.
Probably not. Is he going to probably not bother to check anything until, like, we get back from spring break? Probably not till the Monday we get back from spring break. So, like, if I were you, I would try to finish things before I leave and go on vacation so I don't have to, like, scramble when I get back. But if you don't, Mr. Kulik isn't going to notice because he's going to check this the Monday morning comes back to work. So just nobody freak out. Fair enough?
Yeah, so